So hello, everyone. My name is Konstantin. I'm startup operator at Protocol Labs, and I will go with you today through introduction to IPFS and Filecoin and how they shape the future of Web3. So we will run through a short introduction of, first of all, what is Protocol Labs, IPFS and Filecoin. Protocol Labs is an open source research and development lab, which is building protocols, tools, services to improve the internet. One of the core components of Protocol Labs, or the core protocols which we develop, are IPFS, which is a peer-to-peer protocol making the web upgradable, resilient, and more open to exchange. Basically, it's a data layer protocol. It's a data exchange. It allows us to exchange the files in a peer-to-peer manner. And then there is a Filecoin, which is a decentralized storage network which stores humanity's most important information. It's an upgrade to IPFS, or it could be run separately, which I will explain to you further on. But basically, one second. Is it all good? Yeah. So maybe just a short recap. Basically, Protocol Labs is an open source R&D lab, which is building protocols, tools, and services to improve the internet. And we have many components such as IPFS, Filecoin, libp2p, and many other protocols. But major familiar for everyone are IPFS, which is a peer-to-peer protocol which makes the web upgradable, resilient, and open source. And it's a peer-to-peer data exchange layer for the Protocol Labs and also for the Web3. And we have a Filecoin, which is a decentralized storage network to store humanity's most important data. And it's a layer to ensure that your data is being persistent and being available across Web3, across IPFS, and therefore you can ensure your projects or solutions on top of that data layer. So what we'll go through today. First of all, we will go through the core concepts of IPFS and Filecoin. We also go through the tools for builders, which is the most important topic for you, I believe, to really quickly start hacking on a project on that kind of hackathon. Thanks a lot to Start Summit and Start Hack for this amazing opportunity to meet with you all. And also, the next points of the agenda will be basically going through the possibilities of Web3, what are the learning resources, and we'll have a short discussion and Q&A to answer all your questions as well. So starting with the core concepts of IPFS and Filecoin. We have the internet. I mean, you all are familiar with it. And there was an evolution of internet happening all the time we're using it. We started with a Web 1.0 internet, which is read-only solution. It's a static website, you cannot interact with them. Then we go to the Web 2 solution, which is a read and write. It's most familiar for you at the moment right now, I believe, from LinkedIn to Google to Gmail. You are able to interact with it. It also shows some static files. So that's how we live right now. And believe me or not, we are slowly coming to the Web 3.0, which is read, write, and trust, where trust is an operative thing, and it allows us to achieve verifiability online. It doesn't mean that, so what it means to us is basically that we can trust what we're operating with, and there is a layer which ensures the quality of the content, the quality of information, and the quality of operation of the parts of the internet. And in order to have a transition between Web 2 and Web 3, there is multiple steps which are needed to do so. I assume we all agree that data, information, and knowledge are a couple of the most important assets in the connected era. They are critical for us. They're critical for the human development. And that's why we, as Protocol Labs, as an open source company, believe that the data has to be safeguarded and it has to be in the hands of people. The problem is that right now it's not so. And most of you are familiar with centralization of the data. You all know Google Cloud. You all know just Google tools where it's either them or you are not using them. There is Meta with Instagram, Facebook. And the problem with all these systems is that they are heavily, heavily centralized. And you are familiar with that. If something goes down, if Meta goes down, you are losing access to all your data and you cannot do anything about it. That's what we also see as a fault in the current model. And that's what we are trying to also change with development of the Web3. As you go further, as you go first decentralized, then distributed, these problems could be solved, though it's a long journey and a lot of technical solutions need to be developed on the way to it. So how to become distributed? How do we get the world of the internet to being resilient, performant, scalable, secure, efficient? There are many, many layers which comes to the topic when you start owning your data, or when there is no single source which all the data is attached to. And that's where the privacy starts to play a huge role, where verification starts to play a huge role, and where the non-silent data starts to play a role. Over the next 30 minutes, I will go you through the IPFS, which is a peer-to-peer hypermedia protocol for content addressing. And I will also give you information about Filecoin, which is the world's largest decentralized storage network. And believe me or not, files and folders, they might sound boring, but they're definitely not. So first of all, what is IPFS? IPFS is Interplanetary File System. File system is simply files and folders, which you're all familiar with. What means interplanetary? Interplanetary for us means distributed. There is no single central server to which everyone has to be connected in order to retrieve the data. We try to build our system, or we build our system resilient and online first. And to explain interplanetary in a good manner of planets, with an example of a planet, imagine that you want to have a content being sent between Mars and Earth. In order just to send any content of data, meaning a light, you will need to have at least an hour for requests to go down and come backwards. Though, if someone has already the data on the Mars, which you would want to have access to, you don't need to send a request to Earth and backwards. You just request it from the Mars already. And that's how you basically eliminate the problem of a long delay. And that's what exactly interplanetary and distributed means. This means that there is no single server and everyone have a copy of data, which you potentially would need, so that once you need it, you can just access it from the nearby person and not go to a direct centralized server to get it. And IPFS is distributed by design. There is no single server which have an authority for storing content, and then there is no central server which needs to be contacted to obtain the data. So IPFS addresses the content by what it is instead of where it is. And that's just awesome. Imagine when you're looking for something in the internet or just generally need to access the data, you basically go to a URL where the content is located. And to give an even simpler alternative, when you want to find a friend, for example, you just go to the address where he lives, or you do a phone call to his number he is associated with. But imagine that instead of doing so, you can directly search for his unique parameters, let's say DNA or something else like a face or a fingerprint. Imagine that search could be possible for querying everything, but for querying all the people. But at the same time, it's quite fast because people can say, oh, you don't need to query all the people. You can just ask his friend where he's at the moment. And by 5 handshakes, you can connect all the world, as some people say. That's the pretty similar way how IPFS can locate the data which you're storing. And IPFS provides you an opportunity to locate the content with its ID. And how to do so? Basically, you replace a folder or a file location with a content identifier. Content identifier, or CID in our case, is a way to locate the data, but also the way to describe the data. So what CID does is basically a unique identifier which can encode any object or file or anything with what you would like to store with IPFS and provide a unique identifier to it. So you input a file, which is, for example, here, the hello world text file. You apply a cryptographic hash function to it, and you receive a CID of this object. The cool thing about turning the objects and files into CIDs is that every time you put in the same cryptographic function a same object, you'll get the same CID. So imagine two people uploading the file from different places, but they still upload the same CID, so they can download the file from each other and don't even know about this or be efficient. When you come to the internet, we have right now, for example, there is a lot of content which is being replicated. Think about memes, for example. We have many copies of them all across the world, and this is burdening the file storage solutions. Imagine instead of searching through each and every web address where it's stored, you can only store it maybe like 5 times for any object, and then it will be retrievable for everyone on the internet because they know that they're looking for an object and not for the address where it's being stored. Also, once you upload the CID, you can verify that the object you received is completely what you expected. And that's where we come to the verifiability of the Web3. Basically, CID function also guarantees us that if I download an object from a CID, I can then upload the same object and check if the CID matches. If it's not, then there is a failure in the system. Or there is a certain attacks happening on you, but basically there is content which could not be trusted. But if the content which you downloaded from a CID and then you verify by creating a CID out of it is the same, then we can verify that the object you received is the same. And the beauty of it, that you do not only apply to single objects like an image or an audio or whatever other content you want to store, but basically the same could be done to the folders. And folders essentially is a special kind of a file which just lists other files inside of it. The core principles here remain the same, so verifiability could also be applied to the folders. And that's where the whole IPFS network starts to build. So here's an example of Merkle direct acrylic graph. What it means, basically you can have structures of folders and objects, and the CIDs will be first unique because all the time the object changes inside, and therefore the CID will be always provided a unique file. But also we can trace if the content of a certain folder changed. So in the image you see the fingerprints, and the colors mean that all the objects are different and the CIDs are different. Imagine someone else's right now want to do a subset of your images and create a new folder. He'll get a new CID, but inside, since the images didn't change, the CIDs remain the same. And basically, a user created a new folder, doesn't replicate the data which is already stored on the net. It's just taking the same CIDs and the storage is already provided. Again, deduplicating the whole internet and basically allowing to store only minimal required amount of data and not extensively needed for server operation through the server-based location. This is what CID brings to the world. And you may ask, okay, that's clear on one computer. That's clear for my local machine, but how does the internet or how does the system operate altogether? And that's where many peers come together. Raise your hands who are familiar how torrent system works or who use them. Basically, the idea is roughly the same. We have many peers in the network which all can store some part of the data. And Each node is a peer-to-peer system, so it connects to the nearby nodes. It doesn't need to connect to everyone, but it connects to the nearby group. And two features which a peer has to have in the IPFS network. First of all, it has to be discoverable. And secondly, it must be routable or reachable. So basically, we need to know that if I ask a network, where can I get a certain CID, or where can I get a certain file, there should be a way to connect all the peers in a way to reach the destination where the file is stored. And that's how our swarm of peers is building for the IPFS network. So in order to also discover what is being stored on the network continuously, right now we only have discussed that you can get a CID and you can basically create a structure of folders or how it's stored. But how do you also do the discovery of that, which is the second part? First you store, then you want to retrieve. And that's where distributed hash tables come with a great help. Distributed hash table is essentially a table which is maintained by multiple peers at the same time. Basically, those peers which are connected to each other. And what they do, they store a key and a value of the information being stored. And basically, that's how they tell the network who is storing what. And each and every peer can query this table in order to reply to your question, do you store a certain file or not? And that's having multiple distributed hash tables across the networks allows us to discover the object. If, for example, I ask a node, for example, peer 6, do you know where a certain file is located? He first queries his distributed hash table. If there is none, he says, okay, I know another peer who is most likely to have your file, and then send the request to him. Either the peer says, okay, I have the file from querying the table, or it can send you continuously to the peers until you discover a file, and basically that peer will send you the version you are looking for. So here, for the content routing, you need to understand basically that keys are either content identifiers or peer IDs, which will basically tell the system where to look for the object. Peers, each and every peer in the system can add the rows to the DHT table and provide a CID which they are storing. Peers can query the files and the DHTs, and peers can also query the DHT to find information and on how to connect to the peer ID, basically how to discover the object, how to route to the object, and how to download it. I hope this is the most technical component of the IPFS, and I will be happy to answer all your questions at the end. So if something is not clear, I'm more than happy to answer that. But basically, this is how it all works in a system. Though the using of IPFS in the wild is a little bit different. First of all, the problem of no nodes, no retrievability. So who runs the nodes and why? Obviously, we want to download the data we upload. You can do that on a local machine, which is pretty simple, but that doesn't solve any problem of exchanging the data with someone else. Also, you can run your own network of nodes. Then you can exchange between the nodes which you run, but then it's also kind of flawed, because why would you want to exchange only between yourself? And you also need to have an infrastructure team to operate that. You can also use a pay pinning service for someone to pin your data, meaning someone will store the content and not delete it over time. Therefore, you know you can retrieve it from someone else. That's partially how the Google Cloud works right now, with the point, but taking in mind that it is not possible to do the CAD content routing. Therefore, if someone uploads the same file, they will create a copy of it and not just retrieve the file which is already existing. Or you, in the end, hope that your file will become popular enough that multiple servers, regardless of the cost or without even a payment, will store it for you, so people are reaching their servers and providing you the access to the data wherever you are located. Does that sound to you as a decentralized and reliable web? Can we store the information on the internet and rely on someone's goodwill and trustworthiness? I would say the answer is yes, but not in the models which you are mostly familiar with and which are dominant at the moment in the world. And that's where the Filecoin comes to the play. Filecoin is a storage designed for Web3 from the ground up. And what it gives us the opportunity to be compatible with the Web3. It allows us to do the verifiable via cryptographic proofs storage. And it's, first of all, a massive decentralized network, which has more than 18,000 terabytes, 18 million terabytes of capacity provided right now. So what is Filecoin doing? Basically, Filecoin incentivizes persistence and verifiable storage designed for Web3. What is a Filecoin? Filecoin is a bridge between storage providers on one side and users who want to store their data. If you want to store data via Filecoin, that means you want to pin the data and you want to ensure that it is accessible over time. This is what a Filecoin deal is. So imagine you want to have a file which is stored and pinned by someone on the network. You upload it to the IPFS network, first of all, and then you say, I want to pin that file through a Filecoin deal. That deal goes to the market, and basically one of the storage providers picks your deal and says, okay, for this allocated solution, I will be pinning the file, and therefore I will get the Filecoin in return from our network as a reward, as a cryptocurrency. That's how deals work. And what that means to you, that there will be a server or a storage provider inside our network, which will first store the file and ensure that this file persists over time, so that when you need it, after a certain period of time, you can retrieve it directly from him and do not rely on having your own local nodes or running infrastructure on IPFS. The beauty of the Filecoin deal is that you can repeat it after a certain point of time, meaning that you will get again and again to sign the deal, but basically have a control of how long the deal will stay on the Filecoin network. If you don't need the file anymore, you just stop the deal, and therefore the storage provider will delete it, and the file is no longer accessible through the network. Also, Filecoin network and Filecoin deals are integratable with any data solution which is available at the moment on the web. You can also ping the files from the cloud, which means that you were a cloud user, you were using some of the cloud solutions, you started and you wanted to move to a Web3 to be distributed, to be independent of a single central provider. You can do so immediately. You just do a deal and boom, you'll have a CID of your file and you will know that someone on the Filecoin network stores your data. And it could be, again, used as a backup. So no one says that you should stop using your cloud solution if you find it more useful. Though we also want to say that from our estimation, it's up to 100 times cheaper at the moment to store the data on our solution than on Google Cloud, AWS, or similar projects. So there is also an incentive for everyone in the network to use it as much as possible to build the resilient web. In the interest of time, I will a little bit skip this next slides. Basically, storage deal. This is a more detailed explanation how the files are being renewed, and that you have a contract, you can have a permanence through the smart contracts, through interacting with our market to repeat the deals again and again until you need the file. We also can do the redundancy, ensuring that there is no central solution or there is no central storage provider which sends you all the deals. And then basically if he fails or if something happens to his storage facilities, you don't have access to the internet. So replicating or creating the redundancy of the files, as I mentioned to you before, 5 is what we say is the beginning optimal number, and then it's up to you to decide how many replications do you want. But basically, it ensures that regardless what happens to a single storage provider, if he maybe shuts down or anything else happens, you still have access to the file, and they will be replicated again and again and again, so that you have a consistent access to all your data. And what I want to say that IPFS generally loves Filecoin. Their interaction is happening, and they are answering different requirements of our customers. First, the IPFS is the best for fast and flexible retrieval of the data. You have the gateways, you have the local nodes, you have the browsers through which you can access the IPFS content. Actually, right now, the Brave browser have the local IPFS node installed automatically. So instead of running your node for IPFS, you can just put the CAD directly in the Brave browser, and you will find it automatically, which is an awesome integration. I think there are more coming. We are talking with a few more partners. And generally, this will be more and more available for all users, regardless if you're familiar with node running, with setting up your own IPFS node, or you just want to utilize the files. It's also possible to actually access them from the public gateways. For HTTPS gateway, you can also have an additional solution for running, viewing them in the browser right now, though it's a load balancing thing. So the more people query, the slower it works, basically. And then together with IPFS, you can also run Filecoin, which ensures that the data you're running is persistent and verifiable, and your content is, when you need it, available to you. So this was a brief introduction to IPFS and Filecoin. This is only the top of the iceberg and top of all the solutions we're developing right now. I hope it became a little bit clearer on what IPFS is, on how you can utilize Filecoin. But for interest of the hackers here today, I'll also go through the tools for builders, which gives you the opportunity to build very fast, very easy, and without a hassle, operate with IPFS and Filecoin directly. So first of all, I would love to show you FreeCost. Basically, all the solutions which I will show to you right now are based on top of IPFS and Filecoin, but they give you an easy API to interact with that. And they do all the deal making, all the node running in the background, and you only utilize the useful functions out of that. So FreeCosting is basically a fast, modern, and censorship-proof website that allows to host your solutions and base your websites and app in an open web. It also works with the most modern frameworks like Docker, Gatsby, React, or all other solutions. And it's working as simple as possible. So it just connects to a GitHub repository, you add your build settings, and you deploy the file, your website to IPFS. And it's being backed by Filecoin, meaning that it's persistent and available across the time. You don't need to you don't need to have a deep interaction with IPFS, but if you do it like that, it runs basically on your existing solution, but it's also available in Web3. It's also free, which is an interesting case. And all your data will be backed by IPFS and Filecoin, so you can interact with it way easier and way faster than you typically do even in the Web2 right now. And it also handles all the hosting problems for you. So personally, I am just pro this solution. It emerged quite recently, but I see a huge potential to it for any kind of website applications. Then when we're coming to the storage topics, imagine if you don't want to use fully powered Web3 website, but you still want to make sure that your content persists all the time. That's where the Web3 storage is the best solution you can think of. First of all, it's also based on general IPFS and Filecoin applications. It provides you familiar interfaces to just utilize it. And the way to interact with the storage on IPFS with Filecoin is basically changing exactly 2 lines of code in your web solution in order to store a file on IPFS. And that's just as simple as it could get. So basically you do some operations to call IPFS network, and you get an API key from the Web3, and all your data will be sent to Web3 Storage protocol, and it will be automatically stored on IPFS and pinned 5 times in order to ensure the persistency. Web3 Storage also provides you 1 terabyte of data storage for free right now, and there is no problem to exchange to increase that number even more if you need so for your development of the project. So just feel free to use it for any storage of the data you develop in your projects, and that's how simple the Web3 is right now for developers. This also supports JavaScript and Go client libraries. You also have an HTTP API and remote pinning service, and you have a web interface through which you can interact and basically store all the data for Web3. And maybe the most simple solution out of all shown, and maybe the most hyped word right now in the Web3 space, which is NFTs. We also have an NFT storage, which is a most simple version of storing on IPFS and Filecoin. And basically, most of the NFTs in the world, which you know right now, are stored on IPFS and backed by Filecoin. So here, it's even simpler API. You upload the file, it creates a CID of it, and you store the CID is in the metadata of your object on the blockchain. The reason for storing CIDs instead of the actual content, for example, on Ethereum, it's very costly, or on most networks, it's very costly to store the object itself. For Ethereum, I checked 2 months ago, it was that 1 megabyte of data costed to $55,000, which if you want to create an NFT and then you want to put like 5 megabytes of data into it, that's already not feasible. But if you store a CID, where a CID is just 30 symbols, that's very cheap to store, and that makes a lot of sense to use the CIDs wherever you can, because you store offline, but you cryptographically ensure that your content is available online at any point of time for you. And backing it by Filecoin ensures the content persistency, which in the end allows you to not worry that your content on the NFTs or wherever else will be not available at a certain point after a certain point of time. We all know that, or there is a statistics that says that an average lifespan on a website in the internet is around 1 year. So I wouldn't rely my data on such a short lifespan if I'm building my startup or a project, and then some of the assets are being lost in the period of time, and basically no one have access to them anymore. Ensuring the content persistency is what makes Filecoin and IPFS interesting for the users, and at the same time, it just makes sense in the web to have the control of all your own data. There's also one more solution, which is available for the developers, which is PowerGate. And it's basically a Docker container wrapped around IPFS node and Filecoin, which allows you to do a simple stage store and retrieve of the data. It's the default configuration for minus selection, basically for all who provide storage on our network. And it's just an additional layer. If you want to be fully in control of your data, you can operate it through the PowerGate, and we advise you to do so. So it's just an easier tool if you want to build a fully powered solution once you're ready to scale your project or startup out of that hackathon, as I really hope you do. So the next element of the agenda would be possibilities for Web3. I'm not sure if you already know or have an idea of the startup or of the project you're planning to develop within this hackathon, but I'll provide some more ideas on how to do the architecture and structure of the web of your project with IPFS and Filecoin. So basically, any Web3 enabled architecture looks pretty much like this. You will have a certain front end. Either it will be an existing Web2 solution, or you will use a Web3 solution such as Fleek. You will need some logic layer, which will be a standard application logic or smart contract. You can do the logic with smart contracts on Ethereum network, on Near protocol, or on any other solution which you potentially want to use. Then you will use storage helpers, which are basically the solutions I already explained to you, including Fleek, including Estuary, including NFT Storage, and many other projects which we develop. Feel free to check that out. The Protocol Labs, IPFS, Filecoin, it's very lively community. It's all open source, so you can just use whatever you want for free completely. And then all the storage helpers are again connected to Filecoin and IPFS nodes. And the storage helpers allow you to operate that seamlessly without building your solutions completely out of scratch by yourself. Maybe as we are all still in a hackathon, there's still some projects ideas to share, which we see as a great opportunity for upcoming Web3 and what is still not fully developed, or we haven't seen the solutions which are built like this. And we are looking forward to see something like this publicly. And I'm happy to go through some of them. I personally really believe that the potential of NFTs is not yet explored. And frankly, I am a gamer myself. So there is a huge potential in exchanging the data through NFTs, or for example, storing your data across platforms. It's not only applicable to gaming, by the way, but generally all solutions which require storage of data cross-platform, cross-chain could use NFTs for that and basically enable the system for storage of the data, linking of the data of the assets, but at the same time being independent of a platform for which you're developing. You can also build a social network with IPFS and Filecoin. You can create the content, you can store the content and link and store this content as IPFS objects. For example, it's pretty nicely working for Twitter and just storing the tweets as either JSON objects or even text files, and then storing them on IPFS network, and on the fly in the browser, pull these objects from the IPFS network, will create you a simple social network. You can also do the web archiving from with IPFS and Filecoin, basically backing up all the knowledge. We are already in a good partnership with Internet Archive, with Wikipedia. Basically, most of the most valuable knowledge on the planet is already backed up by IPFS and Filecoin. And if you believe that you have a solution to back up even more knowledge, we're more than happy to provide you the storage, the opportunity, and ensure that the content which you find valuable will be persistent across the time. And these are a few of the examples which could be possible. Let me know if you have any projects or ideas in mind which you would like to see if that's applicable to IPFS and Filecoin, or I know that many of you will be building for some other case partner projects. What I will say that, and this will be also announced later on the stage, but basically our case could be used on top of any other case partner, meaning that if you build a project for the other case partner and you use IPFS and Filecoin there, you're automatically qualifying for our prizes as well. And we are encouraging you to build for any kind of solution, for any kind of application you are interested in. There is a huge opportunity in the Web3. There is way more to be built, and anything which you believe is valuable, we are also encouraging to store the data secure, resilient, and decentralized. I would say we're coming to the end of the presentation from my side, and we are ready to go for the Q&A session in just a minute. I would say also that for the streaming part, we are mostly finished, and we are ready to, and I would say thank you also everyone who were viewing us online through the stream or will watch the recording afterwards. That was a great pleasure to explain to you all the opportunities and the vision of IPFS and Filecoin for the Web3. Thanks everyone.